Okay, in this video we're talking about absolute value inequalities. Okay, so we're going to solve them and then we're going to represent them as an inequality, because that's what your answer is going to look like to begin with, and then as an interval notation, okay, and then we're going to graph it on a line graph so we can see what it looks like in these three different ways that we can represent things. Okay, so first we're going to start with less than inequalities. So remember from, hopefully, what an absolute value means is that if we're someplace on a number line and we want it to be 12, so that all these numbers have to be within 12 units, right? Less than 12. So everything has to be less than 12. If we think of it like distance, then it's everything has to be shorter than 12 units away from you. So it could be 12 units to your right, or it could also be 12 units to your left. Okay, so we need to think and set up two equations. One of them is that this thing has to be less than positive 12, but also over here it has to be between here, right? It has to be in between these two values in order for that to happen. So we have two equations. The first equation is, of course, that 2x plus 4 is less than positive 12. And the other one is that 2x plus 4 has to be greater than negative 12. Okay, greater than negative 12. And we saw both of these two equations, and you get your two different types of solutions. And we get x is greater than negative 8, or we get x is less than positive 4. Okay, so anytime if we have numbers between negative 8 and positive 4, then you can have an absolute value that's less than 12. Okay, so we write this as 1, right? We combine this into one inequality, that negative 8 is less than x, which is also less than positive 4. Okay, so that's how we represent it as an inequality. We can also represent it as an interval notation. So because these are less thans, we're going to use parentheses. So from negative 8 to positive 4, both of them in parentheses, that's how we do it as an interval. Okay, and as long as we know that it's a domain, that it's an answer, that's not going to be a point, but rather going to be a solution set. Okay, so if we're talking about a line graph, that would look like this. Of course, we have your x-axis. We have positive 4 on the right and negative 8 on the left. There are open circles because it's not equal to, and then we shade everything in between. So all of the numbers between negative 8 and positive 4 are solutions to our problem. Okay, so that's how we write it as an inequality, as an interval, and then as a line graph. So one other quick method, let's look at this next one. Okay, and this is what I call the sandwich method. Okay, so what happens is we make a sandwich, of course, where we bring this number to the left side, okay, as a negative, right? Negative 20 has to be less than or equal to this thing, which is therefore less than or equal to 20. Okay, this takes both of your equations from before, right? The greater than over here and the less than over here. Okay, and it makes it into one nice answer so that you're going to get something that looks like what we ended up with. Okay, and if we're going to use this, it's not a real method, it's just something that I do sometimes, so it's not, like, don't quote me on this, it's not on the internet or anything. But you solve it through the middle, and we get negative 14 is less than or equal to x, which is less than or equal to 26. Okay, so at one fell swoop, that gives you your inequality solution. Okay, which we can therefore represent as an interval using brackets, because brackets are less than or equal to. And we can graph this on a line graph simply by putting negative 14 with a closed dot, positive 26 with a closed dot, and then of course shading everything in between. Okay, so anytime we have a less than inequality, okay, less than or equal to, you're going to end up with this solution set being in between two values, right? It's a closed interval from negative 14 to positive 26. Always in between two values if we're talking about less than a certain number. Now, the other hand, we have greater than inequalities. So once again, remember what this means. Okay, an absolute value greater than 3. So if this is our 3 units away from 0, we're talking about everything over here, bigger than positive 3. Okay, or if this is our 3 units to the left, then we're talking about everything over here, right? So this one, x is going to be greater than some number, but over here, x can be less than some number with the way that the integers work. So once again, we have to write two equations. The first one is the given x plus 7 has to be larger than 3, but the other one, x plus 7, has to be less than negative 3. Okay, in order for our solutions, right, greater than, we want to be greater than, farther away from, more than 3 units away from where we start. Okay, so solving both of these, we get x is less than negative 10, or, and here's the key, or x is greater than positive 4. Okay, so that's your inequality, both of those things together. Either x is less than negative 10 or x is bigger than 4 is how we represent this as an inequality. Okay, as an interval, everything less than negative 10 starts at negative infinity. Okay, and it comes up to negative 10 with parentheses. Okay, and then we use this little u, the union, right? We connect this negative 10 set to this other one where everything is bigger than 4. So from positive 4. So in an interval notation, if you remember, the smaller thing goes on the left and the larger thing goes on the right. So all the numbers less than negative 10, well, the smallest number less than negative 10 is negative infinity, and then up to negative 10. And then here we have bigger than 4, so 4 is your smallest value, and then infinity. Okay, and this is how we write it as an interval. So this is interval notation. And then the last kind is as a number line. So in the number line, you start at this number, of course, negative 10 with an open circle and everything to the left. And then here we have positive 4 with an open circle and everything to the right. And this is how we're always going to solve those greater than problems. The numbers are going to be on the outside and go on to the left and to the right. Okay? So we can also simplify this and use the sandwich method. It takes a little bit more interpreting. So negative 13 is greater than or equal to x minus 2, which is greater than or equal to positive 13. Okay, and once again, we solve this from the middle. If this is something that you want to use, go ahead. If not, that's fine also. Okay, but now we have to do a little bit of interpreting. Okay, because we have to represent this as 2. So this is one idea, right? The fact that x is less than or equal to negative 11. Or, here's your other idea, that x is also bigger than or equal to positive 15. So that's how we write this as an inequality. This is not inequality notation, okay, for greater than. This is not how you represent it. You represent it like this. So you have to change from this sandwich method to the actual presentation-wise. Okay, so as an interval, once again, that's from negative infinity to positive, or rather negative 11 with a bracket. And then again from positive 15 on to positive infinity. So brackets when it's equal, infinities are always parentheses because you can never actually make it to infinity. Unfortunately, it might be kind of neat. So negative 11 gets a closed dot and everything to the left. Positive 15 gets a closed dot and everything to the right. So as an inequality, as an interval, and as a line graph. So you are free to use the sandwich method or not use the sandwich method. This is completely my own. It's not something you're going to find in a textbook or on the internet as something official. Okay, but it might just help you solve these things in one step, which I hope this video has helped you to do.